Hi students, good morning to all. So today we are going to discuss the topic laws of chemical combination. Okay, so there are different laws which govern how an equation to be or how a reaction should proceed, or based on that reactions we have derived some laws. Okay, we can say these laws determine how the boundary of the reactions or different how a reaction to be. So out of that, the first law what we are going to learn here is the law of conservation of mass. So this is a fundamental law as well as a universal law which is applicable everywhere actually. So coming to chemistry, we can say what this law is stating. Okay, this law is stating that mass can neither be created nor be destroyed in a chemical reaction. So that means what? Actually you have reactants and products are there. So initially you will take some amount, we say that as the mass, total mass of the reactants, and after the reaction has completed, so when the reaction has completed, we know that the reactants are converted to products. Then if you measure the mass of the products, we can say that that mass will be same as the mass of the reactants. That means no mass is extra created or no mass has disappeared. Okay, so if you look at the statement, you can see here, according to this law, the mass can neither be created nor be destroyed in a balanced chemical reaction. This is the fundamental law. And we can see here two possibilities are there. This is very important with respect to entrance point of view. We can say in some cases the reactants will be completely converted to products. That means all reactants will be converted to products. And in some cases what will happen? All reactants will not be converted to products. For example, in the case of limiting reagent, or some reactants will left behind. So we can represent this law in two ways. So first way you can see here, if the reactants are completely converted to products, we can say the total mass of the reactants will be equal to total mass of the products. That means all the reactants are converted into products. There is no more reactants after the reaction. Now the second case is what? Actually, if the reactants are not converted into products completely, in that case what will happen? The total mass of the reactants will be equal to what? The total mass of the products plus the mass of the unused reactants. Okay, so these are the two ways with which this law can be depicted. Okay, and who proposed this law? We know that Lavoisier, he proposed this law, and who tested this law? There is another person called Landolt. Okay, this law was tested by another person called Landolt, Landolt, Landolt. Okay, so the law was proposed by Lavoisier and it was tested by Landolt. Okay, now we will try to see this law with some examples actually. Okay, so that you will get a fair idea of what this law is. Okay, so we will go into examples. So it's just a simple example where so that you can understand. This is a very easy law compared to the other laws, and you can easily get marks if this question is asked actually. Okay, now the example, for example, I am taking a a hypothetical reaction where A plus B getting converted to C plus D. Okay, consider this hypothetical reaction. Now assume that you have taken 10 gram of A and 10 gram of B. Now we know that if case 1, what is case 1? Okay, first I will explain case 1. Case 1, if A and B are completely converted to C and D. Okay, so if A and B are completely converted to C and D, then what will happen? We can say that the total mass of C and D combined, C and D will be equal to 10 plus 10, that is equal to 20 gram. Okay, this does not mean that C will be 10 gram and D will be 10 gram. Don't think like that, because we know that 1 mole of any substance will have different weight. For example, 1 mole of sodium, you will have mass 23 gram. 1 mole of magnesium, it has mass 24 gram. And 1 mole of, if you say hydrogen, it has 2 gram. So here it is 1 to 1 mole, 1 mole. 1 mole of A react with 1 mole of B to produce 1 mole of C and 1 mole of D. But the mass will be different. But we can say that if you take the mass of this, you taken 10 gram of A and 10 gram of B. In that case, output C and D, if you add, let it be 20 gram, this 20 gram can be 15 plus 5 or it can be 17 plus 3, different. We don't know. We don't want to think about that. We talk about the net mass of the products will be equal to what? 20 gram. Okay. So this is how the law of conservation of mass will be proved. Okay. Now what is the second case? Case 2. So case 2, we can say that if A and B are not completely converted into C and D, are not, very important, completely converted into C and D, then we can say that total mass of C and D, let us assume by measuring we found that it is only 15 gram. Correct? Just assuming. So can we then we can say that mass of unused reactant will be equal to how much? We know that total 20, 15 is there, so it will be 20 minus 15, that will be 5 gram. So I can say that the total mass of the reactants, that is 10 plus 10, 20, is equal to total mass of C and D 15 plus mass of unused reactant 5. So that 15 plus 5 will be equal to 20. Again, the law of conservation of mass is proved in the second case. Okay, so I hope you understood what is law of conservation of mass. Very simple. Mass can neither be created nor be destroyed in a balanced chemical reaction. Okay, so I hope you understood. You got a fair idea regarding law of conservation of mass. Next we will go to the next law. Okay students, next we will discuss a question based on the law of conservation of mass. So please read the question. You could see, if 10 gram of calcium carbonate on heating gives 4.4 gram of carbon dioxide, then determine the weight of calcium oxide produced in quintal. Okay, so this is the question given. So how we can do this question? First of all, we need to write the balanced chemical equation regarding the same. So it's a decomposition reaction they were talking about. That means calcium carbonate on decomposition will give you calcium oxide plus carbon dioxide. So we know that this is a balanced equation. 1 calcium is there, here also 1, 3 oxygen. So here 1 plus 2, 3 are there, and carbon 1 is there, here also 1 is there. So this is a balanced chemical equation. Now what they are telling? They are telling 10 gram of calcium carbonate is taken. So 10 gram of calcium carbonate is taken. And on heating it gave how much? 4.4 gram of carbon dioxide. 4.4 gram of carbon dioxide is obtained. And they are asking to calculate the weight of calcium oxide. What is the weight of calcium oxide? In terms of what unit you need to find it out? Quintal. Okay. In terms of quintal. So we know that as per the law of conservation of mass, the total mass of the reactants will be is equal to the total mass of the products. So here we assume that the complete calcium carbonate is converted to calcium oxide and carbon dioxide. Okay, since nothing is mentioned in the question. So we say that the total mass of the reactants, that is the total mass of calcium carbonate, which is equal to 10 gram, is equal to the total mass of calcium oxide, which we don't know. Okay, we assume that as X, plus total mass of carbon dioxide. Total mass of carbon dioxide, that is equal to 4.4 gram. Now how to find out X here? So X is equal to 10 minus 4.4. So we can say that the total mass of calcium oxide in gram is equal to 10 gram minus 4.4 gram. We know that 10 minus 4 is 6. So 10 minus 4.4 is 5.6 gram. So we got the answer, how much amount of calcium oxide in gram only we have got. So we need to convert this into what? Quintal. So we need to know the relation between gram and quintal. Okay. So we will remember this answer and we will try to convert this into quintal. Okay. So listen here. We got 5.6 gram. So how we can say the relation between quintal? I know that 1 quintal is equal to 100 kilogram. But we need the relation between between grams and quintal. So this can be written as 100 into 1 kilogram. Correct? 100 into 1 kilogram is 100 kilogram. So, and we know that 100 into 1 kilogram is what? We already know 1 kg is 1000 gram. This we have already learned from our classes, lower classes. So I can substitute 1 kg is equal to 1000 gram there. So 1000 gram. So I will get 10 power 5 gram. Now I got the relation 1 quintal is equal to 10 power 5 gram. Correct? 10 power 5 gram. So I will write that only now. So I am rubbing this and I will write my fundamental. Now I have identified 1 quintal is equal to 10 power 5 gram. Now tell me what is 1 gram. Then 1 gram is equal to how many quintal? How to get 1 gram out of this? Divide by 10 power 5 on both sides. So what will happen? If you divide by 10 power 5, this will become 1 gram. And when you divide this by 1 divided by 10 power 5, so that will become 10 power 5 will go upside and it will become 10 power minus 5 quintal. So please remember this. This is another fundamental conversion. So 1 quintal is 10 power 5 gram and 1 gram. How to get 1 gram? Divide by 10 power 5 on both sides. So here dividing, this will become 1 gram. Here also dividing, 1 divided by 10 power 5. Which on moving to top, it will become 10 power minus 5 quintal. Now what is the answer we got? We got the answer as 5.6 grams. So we will do that. Now the mass of calcium oxide in quintal is equal to, we know that we got the answer 5.6 gram. So this can be written as what? 5.6 into 1 gram, and this can be written as 5.6 into 1 gram is how much quintal? 10 power minus 5 quintal. So this is the best way to get the answer. So my final answer will be mass of the calcium oxide in quintal is equal to 5.6 into 10 power minus 5 quintal. This will be my answer. So I hope you understood the question. If you have any doubt, come back to me. Okay. Hi students. So the next law what we are going to discuss under the topic laws of chemical combination is the law of definite proportion, or we say another name is law of constant composition. Okay, so the more meaningful I feel always law of constant composition. So because from that term we can try to understand what this law is actually. And this law was proposed by Joseph Proust. Okay. Now what is this law? Before I go to the statement, I would like to introduce you what this law talks about. This law talks about a particular compound. It can be any compound, any chemical compound. And they say that a particular chemical compound can be obtained from different ways. It can be obtained from different resources, or it can be prepared by different methods. Whatever be the method by which you prepare that particular chemical compound, or whatever be the source from which you obtain that chemical compound, always that chemical compound will have the elements combined together in a definite proportion, by weight. And if you check that ratio, it will be always constant. This is what this law is talking about. So it says that if you take a chemical compound, always it have its elements fixed, always the elements will be the same. If you obtain that chemical compound by any method, always the elements will be the same. And if you take the ratio of its mass, it will always be a fixed ratio. Okay, now we will try to read the statement. Okay, according to this law, a compound can be obtained from different sources, but the ratio of each component means each element in that ratio of each component by weight remains the same. Okay, that is, it does not depend upon the method of the preparation or on the source from which it is obtained. This is more easy if I could explain this example. For example, consider the example of water. We know that water can be obtained from different resources. It can be sea water, it can be river water, it can be tap water or pipe water, or it can be rain water, it can be Ganga water, or wherever water it is. Always water, the formula of water is what? H2O. That means always it will be made up of, from irrespective of the source, it will be always consisting of fixed elements hydrogen and oxygen. And also believe that the mass with which they are combining, here H2O means one hydrogen is having 1 gram, so 2 means 2 is to oxygen 16, so 2 is to 16, this 1 is to 8 is a fixed ratio. This is what they are telling. So if you take water from any resource, or if you prepare water by any methods, always water will have the elements combined together in a fixed ratio, that is 1 is to 8. Understood? So I hope you have understood this law. If you have any doubt, come back to me. So we will try to do a question based on this law. Okay. Hi students. Next we are going to discuss a question based on the law of constant composition or law of definite proportion. Okay. So I want you to read the question. Very important, reading the question and understanding which law to be applied. So if you read the question, you could see here, in an experiment, 2.4 gram of iron oxide on reduction with hydrogen gave you 1.68 gram iron. Then in another experiment, 2.9 gram of iron oxide gives 2.03 gram of iron on reduction with hydrogen. Show that above data illustrate the law of definite proportion. So first we need to think about how this question is related with the law of definite proportion. So I can say that how here they are trying to say is that they are giving you the same compound, iron oxide. But the mass of iron oxide in two cases are different. Initially they are taking 2.4 gram of iron oxide and doing some reduction and getting iron and oxygen. And in the second experiment they are taking 2.9 gram. So they are trying to say that if you take different masses of iron oxide also, but at the end of the day, if you take the ratio of iron and oxygen, Fe is to O, that ratio will still remain the same. That is what law of constant combustion also saying. If you have iron oxide, you are preparing by different methods, or you are obtaining by different sources, or if you are taking different masses, whatever be the case, at the end of the day, if you try to see the ratio of iron and oxygen, that will remain fixed. Okay, now we will try to see how to do this question. So show that above data illustrate the law of definite proportion. Now in experiment 1, you could see here what is the weight of iron oxide, 2.4 gram. Now what is the weight of iron obtained? 1.68 gram. Now I know that I have taken FeO and I know the weight of Fe. Now tell me, we will apply the law of conservation of mass and we will obtain the mass of oxygen. How? Weight of oxygen will be the mass 2.4 minus 1.68. So 0.72. So if you add these two, this will be the mass of iron oxide. So 2.4 minus 1.68, you will get 0.728 gram. Now we need to find the ratio of iron to oxygen, FeO, because FeO only different masses they have given. 2.4 gram FeO they have taken and 2.9 gram of FeO is taken. Now here Fe is to O will be is equal to how much? Iron, the mass is 1.68, is to oxygen we have found out 0.72. Now we will try to make it in simplest ratio. How we do that? Take the lowest number out of these two and divide both numbers. So 1.68 by 0.72 is to 0.72 divided by 0.72. So this value will become 1 and 1.68 by 0.72 will become 2.33. Okay, so we have proved, we have understood that if you take 2.4 gram of iron oxide, the ratio of iron to oxygen is 2.33 is to 1. Now I need to prove that let this mass be anything, whatever be the mass, but always this iron to oxygen ratio should always remain 2.33 is to 1. Now for that, next experiment, in the next experiment also they are reducing iron oxide is reduced with hydrogen, and you are obtaining iron. So weight of iron oxide is how much they have taken initially here, 2.9 gram. And what is the weight of iron obtained? 2.03 gram. And what is the weight of oxygen? Again apply the law of conservation of mass. I know that 2.9 gram minus 2.03 will give weight of oxygen, because Fe, weight of iron with oxygen will give you weight of FeO. So this, if you add these two, it will be 2.9 gram. Okay, so now I obtained weight of oxygen as 0.87 gram actually. Now again I am finding Fe is to O ratio. So I know that since it obeys law of constant combustion, the ratio should remain the same. But Fe here is 2.03, correct. But here I have taken 1.68, but that is not a matter here. So 2.03 is to oxygen how much? 0.87. So 0.87, lowest number is 0.87. I am dividing by 0.87 on both sides. So here you will get 1, and 2.03 by 0.87 is 2.33 is to 1. So that means if you take irrespective of the mass, or irrespective of the source, or irrespective of the method by which you prepare a compound, always the elements are combined together in a definite ratio, definite mass ratio. That is 2.33 is to 1. Here 2.33 is to 1. Okay. So I hope you understood the question. So this like questions usually come for board exams or in your school exams, but in entrance point of view, just you need to understand this, what is definite proportion or constant proportion. Okay, I hope you understood. We will go to the next law. Students, so next we are going to discuss the third law, that is the law of multiple proportion. Okay, so if you see this law, it was proposed by John Dalton. Okay. So what does this talk about? First we will understand that. So in the earlier law, that is the law of constant proportion, was talking about a one particular compound and the elements with which that compound is made up of. Okay, now here the concept is totally different. Here instead of a compound, we are going to talk about elements, okay, that are combining to form compounds. Okay, so if you see the law, according to this law, if two elements combine to form more than one compound, then different masses of one of the element which combine with a fixed mass of the other element bear a simple whole number ratio. Okay, this is the law. Now two things to be highlighted here. First thing is, if two elements, very important, combine to form more than one compound, then the different masses of one of the element which combines with a fixed mass of the other element bear a simple ratio. These are the main points. Now if you see with example, you will understand clearly. Take two elements. Okay, two elements I am taking, nitrogen and oxygen. What the law is saying, two elements can combine to form more than one compound. So if you see N and O combine to form N2O, N2O3, N2O5, N2O4. Okay, then they are saying then the different masses of one of the element. Now if I am taking the mass ratio, N2 means 14 into 2, 28 is to 16. Here 14 into 2, 28 is to 16 into 3, 48. N2 means 28 is to 16 into 5, 80. N2 means 14 into 2, 28 is to 16 into 4, 64. Now, then the different masses of one of the element, you could see oxygen 16 here, 48 here, 80 here, 64 here, which combine with a fixed mass of the other element. Nitrogen, if you see 28, 28, 28, 28, bear a simple whole number ratio. So, what the law is saying, if you fix the mass of one of the element as one particular value, and if you take the ratio of the other elements, that is 16 is to 48 is to 80 is to 64. If you take its ratio, this will be a simple whole number ratio. So this is just a law or observation basically. So if you take any other examples, now here I have taken nitrogen and oxygen. You can take the examples of carbon and oxygen. We know that. Okay, we will do that also. So with carbon and oxygen, how it will be, we will see. So if I take carbon and oxygen, so tell me what are the different compounds it can form? Tell me. So we know that carbon and oxygen can form carbon dioxide and carbon monoxide mainly. So if you see now here you can see more than one compound. So that is, one is carbon monoxide and other is carbon dioxide. Then if you see the fixed mass of one of the element, carbon, the mass is 12 is to 16, here 12 is to 32. So fixed mass of carbon which combines with a variable mass of the other element. So if you take the ratio of the variable mass of the other element, it will be a simple whole number ratio 1:2. So every time they will give some options and ask you which among the following illustrates the law of multiple proportion. Always see in the options whether only two elements are there, because the law talks about two elements combining to form more than one compound. So always check for that. Then this law is very easy to identify from end point of view. One simple example I can say. So if you listen here, I am giving you some set of compounds. Okay. Okay. Okay, if you are given these examples, can you tell me which among the following illustrate the law of multiple proportion? So if you see here in the first example, hydrogen, oxygen and sulfur is there. Three elements are there. Then I can surely say this will not follow the law of multiple proportion. This will not follow. And if you see the next example, carbon and oxygen is only there. Correct. Only two elements. They combine to form carbon dioxide and carbon monoxide. Correct. So this will follow law of multiple proportion. And the next one, if you see, only sulfur and oxygen is there. So combining to form more than one compound. Correct. Then next one, nitrogen and oxygen is only there, forming more than one compound. So the first one does not illustrate the law of multiple proportion, whereas the others illustrate the law of multiple proportion. So I hope you understood what is this law. Very simple. Law talks about two elements which combine to form more than one compound, and there if you fix the mass of one of the element to one particular value, and if you take the mass ratio of the other element, it will bear a simple whole number ratio. Okay, this is what about law of multiple proportion. This was proposed by John Dalton. Okay, students, next we are going to discuss a problem based on law of multiple proportion. Okay, so let us read the question. The question states that the hydrogen peroxide and water contains 5.93% hydrogen and 11.2% of hydrogen respectively. Show that the data illustrate the law of multiple proportion. So how will you understand whether it is law of multiple proportion? Because they are talking about two compounds, hydrogen peroxide and water, and we know that if you say hydrogen peroxide and water, that is made up of only two types of elements. So we say that hydrogen and oxygen combine to form hydrogen peroxide and water. Correct. So as per the law, what we need to do, we take the ratio of hydrogen and oxygen, and it is given like hydrogen, what is the mass given? 5.93%. So we take it as 5.93, then oxygen will be how much? 100 minus 5.93, that is 94.07. Now if I want to find the ratio, what I should do? I should take the lowest number out of these two and divide on both sides. So I will get a ratio 1:15.86. Now I will go to water. And water, what is the percentage of hydrogen given? 11.2. So oxygen will be how much? 100 minus 11.2, that is 88.8. Now I am dividing by the lowest number on both sides. I will get a ratio 1:7.92. Now look at the law. What is the law of multiple proportion stating? Two elements combine to form more than two compounds or more than one compound, then the fixed mass of one of the element. So here hydrogen we have reduced it to simplest ratio, so here it is 1 and here also it is 1. Now the fixed mass of one of the element which combines with a variable mass of the other element, that is 15.86 and 7.92, and if you take the ratio of these two, it will bear a simple whole number ratio, that is 15.86 is to 7.92. If I take a ratio, this will be simple whole number ratio, that is 2.1. 2:1, not 2.1, 2:1. So this illustrates the law of multiple proportion. So in exam, whenever multiple proportion is given, identify the multiple compounds, then make the mass of one of the element fixed, then take the ratio of the mass of the other elements and show that they are simple whole number ratio. Okay, so I hope you understood this law and the problem. We will go to next law. Okay. So hi students, so next we are going to learn the next law, that is the law of gaseous volumes. So this was proposed by Gay-Lussac. So it is popularly known as Gay-Lussac's law of combining volumes. So many of the students will ask me, sir, whether this law, how it is useful for us, sir, how it is useful, because this is just the normal case. We can use this by our stoichiometric method. We can do questions of all the type. So how this law is useful actually, I will explain that. So before going to that explanation, I will go through the statement of this one. Okay, what is this basically? The law is stating like, according to this law, in a gaseous reaction, this is very important. This is applicable. Gay-Lussac's law of combining volumes is applicable only for gaseous reaction. You can see volume will come into picture when gas is there, correct? So it is very important that this is applicable only for a gaseous reaction. So according to this law, in a gaseous reaction, the reactants are always combined in a simple ratio by volume and they form products at fixed temperature and pressure. So how to understand this? Very simple. Now if you see this reaction, H2 gas combining with Cl2 gas forming 2HCl gas. Okay. Now you first thing to check whether if you need to apply Gay-Lussac's law is first to check whether all are in gaseous state. This is in gaseous state, this is in gaseous state and this is in gaseous state. And before I apply Gay-Lussac's law, we will apply our normal stoichiometric concept. So this is balanced now. It is a balanced chemical equation. Now we know that 1 mole of hydrogen combines with 1 mole of chlorine to form 2 mole of HCl. So at a fixed temperature and pressure, we will take that fixed temperature and pressure as STP. Okay. Now tell me, 1 mole of hydrogen means how much volume it will occupy? It will occupy 22.4 liter. Now 1 mole of Cl2 at STP, it will occupy 22.4 liter. And 2 mole of HCl means it will occupy 2 into 22.4 liter. Now if you take the ratio, what will happen? I will divide by 22.4 on all. Okay, because that is the lowest number out of the 3. Now this will become 1 liter, this will become 1 liter and this will become 2 liter. So what is the ratio I am getting? 1:2. Understood? So how we arrived at this? We first we convert taken in the form of mole, then converted into liters, then we have converted that further into simplest whole number ratio. Correct? This is by stoichiometry. Now as per Gay-Lussac, what he is telling is, okay, if all the reactants and products are in gaseous state, don't go by this method. It is always easy that directly you take this one as 1 volume and this chlorine has another 1 volume. This is also 1, right? And this has 2 volume. That means if you take the ratio of 1 volume is to 1 volume is to 2 volume, means that will also become 1:1:2. Understood? This is the way he is telling, but this is applicable if all the stuffs are in what state? Gaseous state. Now the advantage of using this technique is you don't want to convert mole to first into standard volume, then to simplest ratio. You don't want to do that. You can directly put there as 1 volume, this is 1 volume and this is 2 volume. Or you can directly write 1 liter, 1 liter. Volume means it's a common denomination. You can use their liter also, no doubt. So 1 liter, this is 1 liter, then everything should be in liter then. Okay, that is the only use case of this. Now, if you want to understand more how we are using this law to solve a question, that you will see in the next one. We are going to solve a question based on Gay-Lussac's law of combining volumes. Okay, so the point to be remembered here is applicable only for gaseous reaction. Okay, in a gaseous reaction, the reactants are combined together in a simple ratio by volume and form products at a fixed temperature and pressure. Okay. Students, so next we are going to discuss a question based on Gay-Lussac's law of combining volumes. So here, first I will try to do that in stoichiometric method, what we have already learned. Then I will directly apply Gay-Lussac's law. You can see both methods and whichever you are feeling comfortable, you can do that. But please remember that stoichiometric method is applicable only if they say standard temperature and pressure. Otherwise, don't apply the volume concept in stoichiometric method, because at standard temperature and pressure only the volume will be 22.4 liter or 22400 ml. Okay, that is only point to be remembered. Okay, otherwise you can apply Gay-Lussac's law, but Gay-Lussac's law is applicable only if all the reactants and products are in gaseous state. Okay. Okay, we will read the question now. For the gaseous reaction H2 plus Cl2 giving 2HCl, I could see all are in gaseous state. Okay. If 40 ml of hydrogen completely reacts with chlorine, so given is what? 40 ml of hydrogen reacts completely with the chlorine, then find out the required volume of chlorine and the volume of HCl produced at STP. In this question you can see here given is only for one quantity, that is for hydrogen only given is 40 ml is given. Chlorine is not given. What is the given quantity? So there is no concept of limiting reagent here. So in that case we can take chlorine is available in plenty. Then we need to find out with the 40 ml of hydrogen how much volume of chlorine has reacted. Okay. Now, if you see the stoichiometric ratio, you could see here what is the stoichiometric ratio. The equation is balanced, so we can say 1:2. Now, based on this, now as per stoichiometric method, I can write 1 mole of hydrogen gives you 2 mole of HCl, and 1 mole of hydrogen needs 1 mole of chlorine. Correct. Now I know that 1 mole of hydrogen at STP, very important, at STP 22400 ml, not in liters, I am writing directly in ml. Why? Because 40 ml is given. Okay, so 22.4 liter is nothing but 22.4 into 1000, that is 22400 ml. So 22400 ml of hydrogen gives 2 mole is 2 into 1 mole. 1 mole I know 22400 ml. So 2 into 22400 ml of HCl. And 22400 ml of H2 needs 1 into 22400 ml of chlorine. Now this we have written in standard form, but in our given is what? 40 ml. Now I need to convert this 22400 ml to 40 ml. How can I do that? First convert this 22400 ml to 1 ml. So to get converted to 1 ml, divide by, so you can divide by 22400 ml. So if you are dividing by 22400 ml, what will happen? This will become 1 ml. So if you are dividing on the LHS, you divide the whole other terms also by the same number, that is 22400 ml. So here also you are dividing 22400 ml, here also you are dividing 22400. Okay. Now I know that 1 ml of hydrogen gives 2 into, this 2 will get cancelled off. So I can write 1 ml of hydrogen gives 2 ml of HCl, and 1 ml of hydrogen needs 1 ml of chlorine. Correct. Now to me what is given is that 1 ml, no, 40 ml. So how to convert this into 40 ml? Multiply by 40. So multiply by 40 means this will become 40 ml. So do the same thing here also, multiply by 40. So multiplying by 40. So here also multiplying by 40. So you got the answer. So multiplying by 40, this will get cancelled off. You know 2 into 40 is 80 ml, and this will get cancelled off, and this is 40 ml. Okay. So what is the answer then? 40 ml of hydrogen needs how much amount of, will produce how much volume of HCl? 80 ml of HCl, and it needs how much volume of chlorine? It needs 40 ml of chlorine. So this is the standard method or the stoichiometric method I have applied and got the answer. Now I will directly apply Gay-Lussac's law and will try to get the answer. See that. Okay, so Gay-Lussac's law, as per Gay-Lussac's law, how we can get the answer? H2 plus Cl2 giving 2HCl, all these things are in gas. Okay, so as per Gay-Lussac's law, I can directly write 1 volume of hydrogen needs 1 volume of chlorine to produce 2 volume of HCl. Now the question here is how I should take volume. Volume I can, now I will take it as ml. Then I will directly replace volume by ml. Then I can write 1 ml hydrogen needs 1 ml chlorine to produce 2 ml HCl. So many students will have a doubt here. Sir, immediately how you have converted volume to ml? That's why I told this volume is a generic term. This you can make to ml if the question given is in ml, or if you are trying to do it in ml. Suppose if they have given in liters, then I will directly write liter, because all these are ratios. So there is no point in saying the unit actually. Okay, so I know that 1 ml of hydrogen needs 1 ml of chlorine to produce 2 ml of HCl. Now tell me how much ml of hydrogen given to you? 40 ml. So multiply by 40. So multiplying by 40, so this will become 40 ml hydrogen. So multiplying here needs 40 ml chlorine. Multiplying by 40, it becomes 80 ml HCl. Very simple. So you got the answer, that is 40 ml hydrogen needs 40 ml of chlorine and 80 ml of HCl. You got the same answer in the previous method also. But please remember, this method is applicable only if all the stuffs are in gaseous state. If any one of the thing is not in gaseous state, don't apply this method, you will get into wrong answer. Okay. So this is just an understanding so that you can apply any method, but I will always go for stoichiometric method because that is generic. You can apply anywhere, anything. Only thing is that you should, in the question they should have mentioned at STP. Okay. So I hope you understood this question. So next we are going to learn the concept of vapor density. Okay.